Humanity is facing a global crisis in sustainability issues, and there are many proposed solutions to combat these. One such solution is the hydrogen-powered car. Hydrogen is the simplest and most abundant element in the universe and is found in many compounds. Most notably, it's found in water and hydrocarbons, which are a group of carbons that make up fuels such as gasoline and natural gas. However, hydrogen used as fuel in its purest form is much more sustainable and energy efficient than the current use of hydrocarbons as fuel, and may be the solution we need for a more sustainable and eco-friendly future. The main challenge of this form of fuel is getting hydrogen in its pure form. Hydrogen may be the most abundant element on Earth, but is always found as part of a compound, such as water or methane. Therefore, to obtain pure hydrogen, it must be separated from these compounds via various processes so that we can produce hydrogen fuel. Thermal processes, electrolytic processes, and solar-driven processes are the three processes used to produce hydrogen fuel. Thermal processes for hydrogen production most commonly involve steam reforming, a process where high-temperature steam reacts with a hydrocarbon fuel to produce hydrogen. Hydrocarbon fuels that can be reformed to produce hydrogen include natural gas, diesel, renewable liquid fuels, gasified coal, and gasified biomass. In electrolytic processes, water can be separated into oxygen and hydrogen through a process called electrolysis. Electrolytic processes can take place in an electrolyzer, which splits water into oxygen and hydrogen through electric current. And solar-driven processes use light to produce hydrogen. There are different types of solar-driven processes, which are photobiological, photoelectrochemical, and solar thermochemical. Photobiological processes use the photosynthesis of bacteria and algae to produce hydrogen. Photoelectrical chemical uses specialized superconductors to separate water into hydrogen and oxygen. And solar thermochemical processes use concentrated solar power to drive water splitting reactions. Storage of hydrogen gas is one of the major issues when it comes to the use of hydrogen cars. Storage of hydrogen in gas form is the most viable form of storage, concerning its use as a fuel for hydrogen cars, as the gas does not need to undergo any extra reactions or modifications to be accessed by these cars. However, when it comes to storing hydrogen in its gas form, many problems arise. Firstly, hydrogen gas has a very low volumetric density, and the storage requires a very high pressure tanks, typically around 700 bar. In comparison, storage of oxygen tanks require around 140 bar. Storage of hydrogen gas in bulk would be impractical, as very large tanks would be required as opposed to the smaller tanks in which petroleum is stored. This would prove to be inefficient and very costly. Hydrogen could be stored in liquid form, however, to negate this problem of high pressure tanks, and transforming hydrogen liquid into hydrogen gas is not as difficult as hydrogen has a boiling point of only -253 degrees. However, for this very reason, the storage of hydrogen in liquid form requires immense amount of energy and an advanced and expensive technology, as tanks with cryogenic temperatures would be required to maintain its liquid form. Storing hydrogen gas by reacting it with other chemicals is a solution to the storage problems mentioned earlier. However, when it comes to accessing the hydrogen for use in hydrogen cars, it is also impractical, as before hydrogen can be used as a fuel, it must undergo a reaction to return it to its pure gas form. In the context of easy and fast access for drivers of hydrogen cars, this form of storage is not the answer. Therefore, currently there is no perfectly sustainable method of storing hydrogen gas. However, if scientists can achieve a method of storage that doesn't require enormous amounts of energy and reasonably sized tanks, then hydrogen cars may become a very applicable type of car in regards to its sustainability. The main usage of hydrogen as transportation fuel is in cars. To use hydrogen as a fuel in cars, there are two methods: fuel cells or combustion. A fuel cell is a unit of producing electricity using hydrogen, and for cars, this replaces batteries of electric vehicles. In basic, it works by doing the opposite of electrolytic processes in the production. Hydrogen goes into the anode, the positive charge, and oxygen goes into the cathode, the negative charge. Then the fuel cell, as the catalyst, will separate the hydrogen atoms into protons and electrons. Protons will go through the membrane and to the other side of the cell, but electrons cannot, so they will go through a different path, hence creating a flow of electricity. For combusting hydrogen, it works similarly to hydrocarbon fuels such as gasoline and diesel, and uses similar components to gasoline-sourced engines. The key advantage of hydrogen compared to other energy sources is its emissions. Theoretically, hydrogen-powered cars do not produce any carbon emissions, so they can be the best option for achieving zero-emission goals. Also, for both fuel cell and combustion types, car can be filled within a few minutes, just like gasoline, unlike electric vehicles. However, hydrogen-powered cars are still in development compared to electric vehicles due to their multiple hurdles that they need to overcome. The main issue is that there is no reasonable, effective, and compact storage for hydrogen, which is affecting the car's range and affordability. Also, for both fuel cell and hydrogen internal combustion, their efficiency cannot match with electric vehicles. In regards to sustainability, there are 4 main sources of hydrogen: natural gas, oil, coal, and electrolysis, which account for 48%, 30%, 18%, and 4% of the world's hydrogen production respectively. Out of these 4, electrolysis is the only renewable source of hydrogen. It's also the most expensive. The energy used in the production of hydrogen through electrolysis is greater than the energy that can be obtained using it as a fuel. The same energy used to split a water molecule in electrolysis forms a water molecule and releases energy during combustion. Following the laws of thermodynamics, this means that there is only potential to lose energy. Therefore, it is important that the source of energy used for the process of electrolysis is renewable to make the use of hydrogen sustainable. Otherwise, it is simply an extra step in the process of using fossil fuels, in which energy is wasted to the ratio of the energy efficiency of the production process. Currently, industrial-scale electrolysis has an efficiency of 70 to 80%. In the future, it is possible to achieve efficiencies of 90% or higher. However, further research and development are needed to realize this. Although the use of electrolysis to produce hydrogen is not yet cost-effective nor energy efficient, it has great potential as a sustainable and carbon-free energy source when powered by renewable energy sources such as wind, solar, or hydroelectric power. Thus, in conclusion, the search for more sustainable sources of transportation energy, hydrogen fuel stands out as a promising alternative to fossil fuels as it produces significantly lower emissions. Yet before hydrogen cars can become more widely used, production and storage of hydrogen needs to become cheaper and produce less energy than its alternatives. Until then, they serve as a proof of concept for the future of transportation if these barriers are overcome.